Let's take a look at the process of finding function values for a piecewise defined function. When we evaluate a function value, remember that function values have to be unique. So in the context of a piecewise function, it's important to remember that we just want to use one of the piecewise formulas, we just want to use one of the formulas to evaluate any particular value. So -2 in this example, this is an x value. It corresponds to x. It's an input value, as is 5 is an x value, 6 and 2. And so I just want to use one of those formulas for each of the x values. The logic statements tell us which formula to use. So the logic statements are in terms of x. Each of these are in terms of x. They divide the domain, they divide the set of input values into different categories, into different intervals. And so to evaluate the function at -2, when x equals -2, I want to first look at the logic statements, figure out which one of those is true, and there shouldn't be more than one that's true, and then use the corresponding formula to evaluate the function. So -2 is less than 0 when x equals -2. That statement is true and the others are both false. So I plug in -2 into the expression x squared. And so the value of the function at -2 is 4. You might want to pause the video for a moment and try to figure out the values of the other function values. For 5, if we look at the logic statements, this is strictly less than 5. 0 is less than or equal to x. X is less than 5. So 5 doesn't go there, but it goes with the last statement. So I would want to use 16 minus 5, and only that formula to evaluate the expression there. So the value of the function at 5, when x equals 5, the value of the function is 11. At 6, of course, 6 is also greater than or equal to 5, so 16 minus 6 gives me a function value of 10. And finally, when x equals 2, if I look at these statements, 2 falls between 0 and 5, and so the formula to use would be 3 times 2. So the function value would be 6. A word of caution, let me say, so these output values, these are, output values, the function values, these are y values. I think sometimes students learning about piecewise functions for the first time, they're tempted to take these values like 4, 11, 10, and 6 and then plug those into the logic statements. But these are y values. They're values that are coming out of the function, and the logic statements are used to divide the domain. They're used to evaluate which formula to apply. So just be careful, you don't want to use these values with the logic statements. The logic statements, rather, they tell us which formula to use for each input. So those relate to the x values that are the inputs inside the function notation statement. I encourage you to take a moment to work on and try the following question. Let's define g of x as the function that is defined by x plus 1 when x is less than 7 and 5 when x is greater than 7. Using that definition, take a moment and try to find g of 3, g of 7, and g of 10. In a moment or two, I'll talk about the answers. I encourage you to pause the video and try to answer the question yourself first. I hope you took a minute to find the function values for g at each of these x locations. Thinking about the statement, when x equals 3, it makes the first logic statement true, and so the function value is 3 plus 1, it's 4. When x equals 7, the function value of g when x equals 7, well, 7 equality goes with the lower statement, and now this is a little bit different, right? This is just saying the value is constant the function value is constantly 5 for any x value that's bigger than 7. There's no place to actually plug in the x, so we just get a value of 5. And finally, g of 10, 10 is also greater than or equal to 7, and so I use that second formula, which is constant. The function value is still just 5. The graph of the g of x function, just to kind of explain those second two function values, the graph, it's going to be the line x plus 1, y equals x plus 1, up until 7. The value at 7, though, belongs down slightly lower, so this value would be up at 8. We put an open dot there because the value after 7 and including 7 is just constantly equal to 5. So that 5 basically represents the horizontal line y equals 5. Whereas before 7, the graph is defined as y equals x plus 1. I hope you enjoyed the video. Thanks for watching.